Athens, Greece, a 4 million citizen metropolis. Just a mile offshore, Athens directs all of its sewage wastewater to the island of Psyttalia, where it is treated in a modern wastewater treatment plant. The sewage wastewater comes in and is processed to process water and irrigation water. In the treatment plant, sludge is produced and digested, yielding biogas at rates of 2000 cubic meters per hour, which can be used to generate electricity. However, this biogas is polluted with dangerously high amounts of hydrogen sulfide, which will be removed with the DMT BioSulfurex system. This bioreactor uses bacteria to convert H2S in water-soluble sulfuric acid. Since this process is fully biological, no chemicals are necessary. The system is easy but effective. The biogas enters the plant and goes through a biogas blower, after which the gas flow is monitored. In the reactor, the biogas inlet is positioned perpendicular to the air supply, guaranteeing optimal mixing of the gases. The gas mixture and the circulation water flow to the bioreactor's packing media in countercurrent. On this material, H2S digesting bacteria are active. The digestion is a reaction between hydrogen sulfide and oxygen, which yields sulfuric acid and a minimal amount of elemental sulfur. If enough oxygen is present, all H2S is converted to sulfuric acid. Without enough oxygen, more elemental sulfur is formed. The anaerobic bacteria produce a minimal amount of sludge and new bacteria. Continuous removal of reaction products and excess sludge, water sprayers on top keep the packing media wet. When the purified biogas exits the reactor, it is led through a demister to remove any remaining water droplets. While the biogas flows down, the amount of oxygen is analyzed. The airflow is regulated by the ratio between the measured biogas flow and oxygen concentration. For maintenance and inspection purposes, the BioSulfurex can be bypassed. When the reactor is in use, the purified biogas exits the system and is ready for generating green energy. We will now have a look at the circulation water circuit. Water is pumped up to the top of the reactor and is sprayed on the packing media to humidify the bacteria and flush away excess sludge. This ends up in the water reservoir underneath. The circulation water is pumped through a heat exchanger and a filter to obtain the desired purity and optimal biological temperature in the bioreactor. In the circuit, pH, flow and pressure are monitored. Now have a look at the supply water system. The amount of water released is controlled to maintain the right pH level in the bioreactor. The system is controlled with electronic valves and the flow is guarded by flow meters. The air supplying the oxygen for the bacteria is being sucked in from outside by an air blower. The air is filtered and the airflow is measured. The blower is frequency controlled to maintain an optimal oxygen concentration and to prevent any explosion dangers. Data transmitters provide all the information the operator needs about flow, pH and oxygen levels both local and on the control panel. The control cabinet is the brain of the BioSulfurex. It controls every single process parameter. It is equipped with a control screen for the operator and an emergency stop. To control the water reservoir underneath the reactor, the BioSulfurex has an overflow system that prevents the water level from getting too high. Excess sludge is periodically removed by hand. Now we will have another global view of the plant. So, why would you choose the BioSulfurex system? High removal efficiency, above 95%, low energy consumption, no chemicals needed, small ecological footprint, easy maintenance. DMT BioSulfurex, the best system for biological desulfurization without chemicals.